so far we have used only one rule, 2n square rule, but there is a second rule. Remember we discussed that last shell cannot have more than 8. Okay, last shell cannot have more than 8. So let's see this one. First of all, let's talk about this example. Potassium. Okay, potassium is having atomic number 19, mass number 39. So if I write proton will be 19, electron will be also 19. And neutron will be how much? Again, A minus Z. That means 39 minus 90. How much? 20. Is it not? 20, right? So let's try to do the electronic configuration and draw the structure. Now, if I do the electronic configuration first now, here. First shell can have how many? 2, is it not? And second can have how many maximum? 8. Total how many gone? 10. 10 gone from 90. How many more left? How many more left? 9. Is it not? 10 gone from 90, 9 left. Is it? This is not correct. This is not correct. Okay? Why not? Because you may say, sir, maximum capacity of the third shell. If you remember, third shell, 2n square rule for the third shell. Right? Third shell, 2n square rule if I follow. 2 into 3 square. How much? 2 into 9. That means 18. Sir, 18. Is it not? So if 18 is the maximum capacity, why giving 9 here is a mistake? Is it not? I am saying first shell 2, second shell 8 is correct. 9 is a mistake. But why 9 is a mistake? I can give 18 in the third shell. As I know from the 2n square rule, I can give 18 in the third shell, right? But I am not going to do that. Why? Because there is one more rule, remember. Last shell cannot have more than 8. Now, which is the last shell? First, second, third. K, L, M. M shell is the, if I say this is the K shell, this is the L shell, this is the M shell. M shell is the last shell. And the last shell is having 9. Last shell is having how many? 9. Now, last shell cannot have more than 8. Last shell cannot have more than 8. So, this rule is invalid. Means this configuration is invalid, not the rule, sorry. The configuration is invalid. So, what shall we do? We will change it. Since we cannot give last shell more than 8, we will give it 8. And how many more will remain? 1 more. 1 will go to the last shell. So we have K, L, M, N. N is 1. Is it not? We will not have last shell 9. Okay? You must understand that. And one more thing that I should tell you here is, if a shell is filled to the maximum, for example, so let me take the example of helium. Okay, let me take the example of helium. Now, helium has 2 atomic number. That means proton is 2, electron is 2. Right? So if I draw structure, how many shells will I need? Will I need these 2 shells? First shell can get how many? 2. So I've given 2. If I consider the neutron here, which is mass number is 4, so if I consider the neutron here, again A minus Z, 4 minus 2, it is 2. So the neutron is also 2. Proton here is 2, neutron here is 2. I'm not showing it is here, proton is 2, neutron is 2. Fine. Electron is how much? 2. Then do we need this shell? Why will you need this shell? Finish, no more electron to give. So I need only one shell, the K shell. Now K shell is having 2 in the first shell, K shell. It is also the last shell. There is no more shell, is it not? So we will call this configuration a stable electronic configuration. We will call it what? Stable electronic configuration. That means it is having maximum capacity. It is having maximum capacity fulfilled. Means first shell is having capacity 2, it is having only 2 there. Okay, it is having capacity 2, it is having only 2 there. Okay, and one thing that we need to know, that if it is having 2 in the last shell, which is the maximum capacity for the last shell, that is the first shell also, K shell, maximum capacity is 2, it is having 2. It is called a stable electronic configuration. This is also known as duplet. Duplet configuration. Duplet, why? Because 2 in the outermost shell, which is also the first shell, which is completely filled. So this is called duplet. Let's take another example of a stable electronic configuration. Let's take example of neon. Okay, neon. Neon is having atomic number 10, mass number 20. Proton will be 10, electron will be 10, neutron will also be 10. If I show only the electrons, okay, first shell will have 2, second shell will have how many? How many more left? 2 gone from 10. 8 more. What is the maximum capacity of L shell? 8. It is also having 8. So the last shell is the L shell, and the L shell is having 8. Completely filled, having till the maximum capacity. This is also known as stable electronic configuration, just like the previous one. And since it is 8 in the last shell, we call it an octet. Okay, we call it an octet. So there are some more things to discuss about the electronic configuration and its implication on the structure of the atom and also on the nature of the atom. We'll discuss that in the next class.